Under the Arizona sun, giant logs lie turned to stone, not buried, not hidden, scattered, broken, exposed. A desert should not look like the wreckage of a forest. And yet this is not fantasy, it is geology. The wood is real, the grain is real. In some specimens, even the microscopic cell structure survives, which is exactly why the problem gets harder, not easier. If this question has ever stayed in the back of your mind, stay with it. Go to northeastern Arizona, to the Badlands near Petrified Forest National Park, and the first thing that hits you is not mystery. It is mismatch. The land is dry, stripped, and almost brutally open. Low scrub, dust, wind. Clay hills banded in faded reds, violets, greys. The kind of country that feels more like exposure than habitation. Then you look down and find trunks the color of old embers, deep red, black, gold, purple, split open across the ground like something shattered after impact. Some of them stretch longer than a city bus. Some are thick enough that even in fragments they still carry the weight of a much larger body. They do not lie where a modern mind expects a forest to be remembered. They lie across desert flats, among mesas and washes and stripped mineral ground. The scene feels wrong before it feels strange. The accepted explanation is clear enough. In the late Triassic, around 200 million years ago, trees were buried by sediment, volcanic ash, and flood deposits. Mineral-rich groundwater moved through the buried wood. Silica replaced organic tissue cell by cell. The trunks hardened into stone. Later erosion exposed them again. That account is real science. It explains how wood becomes rock. It explains why logs can survive when almost everything else is gone. It explains the logs. But it does not settle the feeling of the landscape around them. Because these are not just fossils in a museum drawer. They are remains in a place that reads like aftermath. The earth looks flayed open, as if softer layers were stripped away and only the hardest evidence remained. The trunks do not feel preserved so much as left over, not hidden from time, passed through it. Blue Mesa makes the contradiction worse. The ground there folds into bands of pale ash, lavender clay, white sediment, and chalky slopes that look almost lunar in the midday light. And across that alien color, pieces of petrified timber lie where a mind trained on ordinary scale has to pause and recalibrate. Crystal Forest does the same thing in another register. Log after log, broken into glittering sections. The interiors flashing with quartz, amethyst, iron and silica under the sun. The mainstream account can tell you how the mineralization happened. It does not erase the violence of the image. A forest stood here once. That part is no longer in dispute. What becomes dangerous is the next step. Because once you accept the logs as real, they stop being curiosities and start becoming scale evidence. They prove that a biological structure can be buried, mineralized, broken, and still remain legible long after the living system is gone. They prove that the land can keep the shape of life while losing the life itself. And once that precedent is accepted, your eye starts doing what it was not doing before. It lifts. Beyond the scattered trunks, the Southwest is full of standing forms that change character the moment the logs are no longer just fossils, but fragments. Mesas, buttes, isolated towers, flat crowns, sheer walls, massive bodies rising out of open ground with the calm, mute presence of things that outlasted whatever once stood around them. Under ordinary conditions, they read as scenery. Monument Valley at sunset, a lone butte in a travel brochure, a flat-topped mass on a highway horizon. Beautiful, familiar, geological. After the logs, they begin to read differently. Not as proof, not yet. Just as a problem. Because the comparison is too simple to ignore once it appears. Debris below, standing mass above, broken timber on the ground, columned bodies on the horizon. A field of fallen remains framed by forms that do not look fallen at all. Maybe that means nothing. Maybe the conventional reading is complete. Maybe erosion, uplift, and deep time are enough to produce both the debris field and the larger forms without any deeper connection between them. That is possible. But if the connection is meaningless, it should fade the longer you look. For some people, it sharpens. The desert begins to feel less like emptiness and more like exposure, less like a natural blankness and more like a surface after removal. The logs stop asking where the forest went. They start asking what kind of world leaves splinters like this behind. And that is where the real problem starts. Because if these stone logs are only what fell, then the mesas on the horizon stop looking incidental. They start looking like what did not. The first thing this question demands is restraint. Wood can turn to stone. That is not fringe speculation. It is one of the best documented overlaps between biology and geology on the planet. Petrified wood can be cut, polished, sectioned, put under a microscope, and read. Growth rings remain, grain remains. Cellular architecture can remain with a precision so exact that the stone does not merely resemble wood, it records it. So start there. A tree is buried fast enough that oxygen and surface decay do not erase it immediately. Water carrying dissolved minerals, often silica, moves through the buried wood. Organic tissue breaks down. Minerals replace it cell by cell. Over time, the chemistry changes while the structure holds. Bark texture can survive. Internal patterning can survive. In exceptional specimens, the microscopic organization of the wood survives so clearly that the original biology is still visible inside the stone. That is the process. The standard model is not weak here. It explains a great deal. It explains why giant fossil logs lie in desert terrain. It explains why a forest can vanish while its mineralized remains outlast entire landscapes. It explains why the painted desert can hold the memory of timber in a place that now feels almost anti-forest. It explains how a world with water, burial, and time can become a world of exposed stone. What it does not automatically explain is every pattern that begins appearing once scale enters the frame. That distinction matters, because the moment people notice a larger resemblance, the conversation tends to collapse into two equally lazy positions. Either everything is secretly a petrified tree, which is unserious, or the resemblance means absolutely nothing, which is too easy. The harder position sits between them. Accepted geology can explain the process while still leaving a broader visual pattern unresolved. Arizona gives you one of the clearest pressure points. In one direction, there are mineralized trunks with visible wood anatomy. In another, there are isolated masses of stone so large and so cleanly separated from the surrounding terrain that they stop reading like background once you have calibrated your eye to the debris field. A log in crystal forest is not a theory, it is an object. A flat-topped mass rising beyond a desert basin is also an object. The geological read-in may classify them separately, and often does. But classification is not the same thing as closure. And scale is where the question stops sounding childish, because the fossil record already allows a stranger biological Earth than most people casually imagine. Ancient plant systems were not simply modern forests projected backward in time. Earlier worlds supported biomass, atmospheric balance, and organism size that break modern intuition. The point here is not that every giant tree claim is suddenly validated by that fact. The point is narrower and more important. Very large biological systems are not biologically absurd just because they are unfamiliar to us now. That precedent changes the temperature of the question. Walk the Badlands long enough, and you start noticing how the petrified logs behave visually. They do not feel like random stones. They feel like parts, cross-sections, fragments, sections of a larger mechanical order now dispersed across a stripped surface. Then the horizon offers its own answer in the form of vertical bodies that remain intact enough to carry mass, profile, and structure all at once. In some light, a butte in Monument Valley does not just look old, it looks cut off. In some light, a mesa does not just look elevated, it looks left behind. Maybe that is projection. Maybe the geological account remains fully sufficient. Erosion does isolate, sediment does harden. Volcanic intrusion does create columns. Time does remove softer matter and leave resistant masses standing. Every one of those sentences is true, but the accepted explanation for how wood petrifies is not the same thing as an answer to why certain landscapes keep presenting the same visual logic again and again. Fragment below, standing form above. Preserved timber here, massive flat-topped survivor there. Exposed debris in the foreground, enormous body in the distance. The logs prove at least one thing beyond dispute. Biological form can survive geological transformation. Once that fact is admitted, a larger question enters the room. If structure can survive mineral replacement at the scale of a log, what happens when the object is no longer a log on the ground, but something vastly larger, weathered differently, classified differently, and interpreted before anyone even thinks to ask a biological question? A piece of petrified wood can be chemically settled. It can be named, measured, sliced. A mesa can also be chemically settled. But chemistry does not settle resemblance by itself. It settles composition. The rest lives in proportion, context, and repeated form. And that is where the tension sharpens. The science explains how wood becomes stone. It does not automatically explain why certain stone landscapes keep presenting the same unresolved pattern to anyone willing to look too long. If the logs are only fossils, that is one story. If they are also precedent, it becomes another. By the time the argument reaches the horizon, resemblance is no longer enough. A flat top can mislead you. Vertical striations can mislead you. A dramatic silhouette in desert light can mislead you. The eye is powerful, but it is reckless. If this question is going to survive contact with reality, it has to move past mood and into structure. So leave the silhouette aside for a moment and go where stronger questions usually go. Measurement. What keeps pulling people back to certain formations is not only that they resemble stumps in some vague atmospheric sense. It is that some of them repeat a specific internal logic. Flat crown, sheer sides, mass concentrated in an upright body, a slight flare or transition near the base, separation from surrounding terrain as if softer material was removed and only a more resistant central form remained. Once that sounds like imagination. Repeated enough, it becomes proportion. Devil's Tower is the most obvious example because it forces the issue in public. The geological reading is direct, an igneous intrusion, exposed by erosion, with columns formed through cooling and fracture. The chemistry supports that. The rock has been tested. The columnar jointing is real. Nothing about this question becomes stronger by pretending otherwise, and yet the structure remains visually unsettling. Not because it perfectly matches a tree stump. It does not. The stronger problem is that it behaves like a repeated ratio. Broad upper mass, vertical body, distinct transition at the lower section, isolation from surrounding material that is now gone. The same irritation appears again in parts of Monument Valley, in isolated buttes across the Colorado Plateau, in flat-crowned masses separated by open miles of stripped terrain. The mainstream account explains each class of formation according to process: erosion, deposition, intrusion, uplift. That may be correct. But repeated process still produces repeated form, and repeated form invites a harder question than people like to admit. What kind of physical consequences would follow if the resemblance meant anything at all? That question changes everything, because now the story is no longer about whether a butte looks like a stump from the right angle. It is about what must exist below the visible structure if the comparison is even worth keeping on the table. Where are the roots? Not symbolically, not poetically, physically. A body that large would not only rise above ground, it would alter the substrate around and beneath it. A root system scaled to an immense trunk would spread laterally, penetrate deeply, disturb mineral distribution, change soil chemistry, alter density, leave radial signatures, transitions, scars in the ground where biological mass once occupied space for a very long time. Even after organic matter was gone, the ground should remember. That is a better question than silhouette because it is testable. Geochemical testing at the base, density mapping, ground-penetrating radar, transitional surveys designed specifically to look for buried radial structure or anomalous subsurface patterning. If the comparison is foolish, those tests should bury it. If the comparison has any substance, those tests should at least produce something worth arguing about. And this is where the whole subject becomes unexpectedly sharp. Because the public conversation rarely seems to reach that level. The visual resemblance gets mocked. The horizon gets dismissed. The phrase, "it just looks like a stump," is treated as if it finishes the discussion. But the deeper issue is not visual at all. It is methodological. For something so visually persistent, the subsurface question feels strangely undershown, under-discussed, almost absent from the simplified public answer. That absence does not prove concealment. It may simply reflect disciplinary confidence. Geology already has working explanations for these formations, and fields do not enjoy chasing questions they consider unnecessary. Fair enough. But from the outside, the gap remains visible. People are told the resemblance is meaningless, yet the strongest way to strip it of meaning, base testing aimed directly at the root consequence, rarely enters the popular closure. That is why this section is the core of the whole story. Resemblance can seduce, ratios can tempt, shapes can mislead. Roots are harder to romanticize. A silhouette can lie. A root system cannot. Maybe the deeper surveys already exist in technical fragments scattered across reports few people read. Maybe the answer is ordinary. Maybe the ground beneath these formations behaves exactly as the geological reading says it should. And the root question dies the moment it is taken seriously enough to be tested. That is possible. But if that is true, one would expect the answer to be easy to show, easy to point to, easy to place in front of anyone who keeps returning to the same comparison. Instead, the argument keeps getting stranded at the level of appearance. And that, by itself, is interesting. Because once the question reaches the roots, the story can no longer stay on the surface. It has to ask what kind of world would make debris fields, standing masses, and missing subsurface answers part of the same chain. At that point, the horizon is no longer the biggest thing in the frame. The loss is. A larger living system leaves a larger wound when it collapses. That is not theory, it is proportion. Burn a field, and you damage a season. Burn a forest, and you change a region. Strip a system large enough to control shade, moisture, soil retention, atmospheric exchange, and the life nested beneath it. And you do not just remove trees. You alter the conditions that made the landscape itself make sense. That is the ecological pressure hidden inside this question. If the petrified wood scattered across the southwest is all you look at, the story stays contained. Ancient forest, burial, mineralization, exposure, time. But the moment those logs stop being isolated curiosities and start behaving like fragments, the ecological cost rises immediately. Fragments imply a body. Debris implies breakage, and breakage at scale is never gentle. Picture what the ground would look like after immense biological cover was burned, buried, mineralized, stripped, and re-exposed over vast time. Not lush ruin, not romantic decay. A harsher thing. Loss of canopy, loss of moisture retention, loss of softer layers. Surface hardness increasing as living cover disappears. Sediments redistributing. Wind working directly on exposed ground. Water no longer slowed by roots and shade. What remains would not announce itself as tragedy. It would present itself as terrain. That is what makes deserts so deceptive. They feel original, final, self-explanatory, open land, dry sky, exposed rock, sparse life. But exposure is not origin. A stripped surface can look native to itself even when it is the residue of something larger that no longer exists. A mesa in hard light looks permanent. A field of petrified logs looks exceptional. Put them together, and permanence starts to look more like survival. The conventional reading is not without power here. Climate shifts can empty landscapes. Ancient rivers can move forests far from where they grew. Volcanic ash can bury ecosystems. Erosion can isolate towers and tablelands out of once continuous deposits. Deep time can perform transformations so immense that the human mind mistakes process for design and aftermath for normalcy. Every part of that belongs in the frame. But even after granting all of it, a harder possibility remains standing. Not that geology is false. That geology may describe the mechanism of transformation without exhausting the memory of form. That is a narrower claim than people assume, and more unsettling because of it. It suggests later civilizations may not have hidden a lost world so much as inherited one. They named what they found, mapped it, classified it, built myths around it, then highways around it, painted the towers at sunset, turned the buttes into symbols of timeless nature. And perhaps most of them are exactly that in the geological sense. But inheritance has a blind spot. You can become fluent in a ruined surface without understanding the scale of what was ruined. That possibility gets sharper when you think atmospherically instead of theatrically. Larger biomass means larger atmospheric participation, more carbon cycling, more water movement, more cooling, more shade, more oxygen production relative to a diminished system. Damage a small forest, and the atmosphere absorbs it. Damage a far larger biological order, and the consequences spread outward. Fire intensity, soot load, sediment burial, hydrological collapse, exposure, long mineral replacement where life once held the surface together. The landscape that emerges later may be geologically legible and biologically unrecognizable. A butte then stops being only a shape. It becomes a question about what scale of loss the modern surface can still carry without admitting it. That is why this story keeps returning, even when it remains unresolved. First, the logs on the ground, then the standing forms, then the ratios, then the root question, then the ecological cost of imagining that the current desert is not original emptiness, but exposed remainder. Once the logs turn to stone, the mesas stop looking like scenery and start looking like survivors. Maybe that is too much. Maybe the accepted explanation is enough. Maybe the horizon is only stone, the logs are only fossil wood, and the pattern connecting them is nothing more than the mind trying to force unity onto landscapes shaped by separate processes. That remains possible. The narrator does not get to declare certainty where the ground has not given it. But the pressure of the question remains because the terrain keeps producing the same sequence in the same order. Debris, standing mass, proportion, missing roots, ecological consequence. By the end of that chain, the word desert no longer feels simple. The petrified wood is not the forest. It is what the forest became after the world that could hold it was broken. A desert is easier to understand than an aftermath. That may be why we chose the desert. And if petrified wood is only the leftover debris, what exactly was large enough to leave the formation still standing?